And before the break, we talked about to determine the center of lines. And now I will talk about this topic, surface of revolution, on Thursday. I will talk about it on 16th of December. Now, and let me go to page 60 first. 59, sorry. Page 59. Now, and we want to determine the centroid of 3D objects. And we want to determine the center of gravity of 3D objects. And now we have, for example, we have something like a pyramid, and what is it called in the? We have something like a pyramid here, and we want to determine the center of gravity in this of this pyramid. Now we are doing the same thing, and if we work it out by integration, and we determine the volume. We want to determine the volume dV here, and then it means we have a dW here, and then we work upward, and then the moments dm is equal to x cross dW, right? So, and by the definition of by the idea of center of gravity, and we assume the total weight of this is equal to W. Then we have, by the idea of center of gravity, we have the centroid here, x bar, and then we have weight W here, right? Okay. This is m is equal to x bar times W, and for this one, and m is equal to for this one. So we say we have the equivalent moments. They are the same moments, and these two are equivalent. This m, the m on the left-hand side is equal to the m on the right-hand side. Okay. Of course, if you want to be exact, and because because the plus z axis is here, so and the moment here is negative actually. That's oh sorry. Or should let me put it this way. The moment is in z direction, right? Next we have and for 3D objects for these 3D objects, I will give you the equation if I need those at the bottom. Okay. At the bottom of the page, you have 3 shapes, and I will give you those if I need them. If I need these 3, if I need this, sorry, if I need these 2, I will give it to you. I'll give it to you. Will be given. Okay. So you don't need to remember this. Is that okay? But one thing, if the shape, if the 3D objects are like triangles and triangles or cylinders and like this, and of course you know. And you should know how to do how to determine the centroid of these shapes, right? Because the centroid of this shape is the centroid of the triangle, and then the height is, if this is h, and this is half of h, right? Is that right? So I assume I think you can do it. But for these 2 on the left, if I need them, I will give it to you. It's okay. So, and let's if you're ready, then we can go to the next page. So we go to the next page. Now, if so for composite bodies, what are composite bodies? Let's have a look at this. Notes the page 50 something. 54. Composite bodies are like this, and if we have a shape which is quite complex, and but it can be we can take it as the addition or subtraction of simple shapes. We can determine the in 2D system, we can determine the centroid of the whole area by the centroids of the different parts. Now, the same thing can be done for 3D objects. The same thing can be done for 3D objects. And for example, if it is and for 3D objects, and if we know the centroids and the volumes, the centroids and the volumes of different parts of a body, it means we can determine the centroid of the whole volume. Okay. I assume you know volume, right? Volume is it's okay. VI here. It's okay. If we know the centroid of x bar, y bar, and z bar of all different parts of the volume, and then we can determine the center of the whole composite body. Now let's work an example. Sample problem 5.12. So locate the center of gravity or centroid of the steel machine at steel of this part. And the diameter of each hole is 20 millimeter. Diameter is this one. Oh. The diameter of each hole is this one. It's 20 millimeter. Machine elements simply means basically like this. Locate is it's okay. Now, the thing we need to determine is this one. And if the figure is not clear enough, let me draw it like this. And it should be, if we look at the part from this side, if we look at the part from this side, it should look like this. If we look at the problem from this side, so it looks like this. It's okay. You will learn how to draw this. You will learn how to draw this in the next semester.
那如何画得漂亮，下个学期工程组就会学。那我现在开始画。
It's okay. now we have so for this part we can see it is a composite body with different components. So take your time to draw this.
那么说起来就以后学画工程图的话，就是每日系的画法跟欧系的画法这样子。应该这个算是欧系的画法，但是这个老师会以后跟大家说。工程图不是一种画法，就是以后就是以后有机会看到有一些欧洲的零件跟美国、日本的零件的话，其实它的工程的画法是不一样的。然后有机会去留意一下。
Okay, now we go to we go to this, and from here we can see that it can be divided into 4 parts. We have this block. This one is this one, and then we have this quarter circle here, and then this one plus this one, and then there are 2 holes, and we can do it by minus this one and minus this one, minus these 2 holes. Okay. Suppose we have this one is 3 and this one is 4. Okay. It's okay. Now, for the next thing, to do this kind of problem clearly, please draw a table like this. Please draw a table like this. And the first thing, please draw a table like this. The second thing, these 2 are these 2 are holes, right? We take these out. So we take these 2 out. So for these 2, it is you can say it is we are adding 2 things with volume smaller than 0. Is that okay? Because we are taking these 2 parts out. So we can say we are adding 2 things with volume smaller than 0. This is the same for 3D problem and 2D problems. I'll give you homework in 1 or 2 days time. Okay, for these two holes, that because we are taking things out, the volume V is smaller than 0. So if we know these 2 are taking out the volume of these 2 parts are smaller than 0, then means we put the minus sign here first. It's okay. Because these 2 are taking out material, we are taking out things. So, I would say, sorry. So we put volume as smaller than 0. That means let you remember that these two are taking out things that put minus sign here and here. Is that okay? So the biggest thing to remember is this one. So now because in the equation we need to determine the centroid of the whole volume, we need the centroids of different parts. Now let me do part. Let me do this part and this fill this in. It's the same on the book. Okay. And here is I can make one remark. Now, if we have, for example, if we have after filling this and we determine and you can calculate the volume of each part, right? You can calculate the volume of each part, and then we calculate x bar b, y bar b, and c bar b. So let me work it out. Work this one. Let me take this as example. This one. For this one. So y bar is equal to minus 20 millimeter, and this volume is equal to minus what I forgot. But to get the results, of course, we have minus. So for this one, the sum of this one is the total volume of the part, and this value is the summation of xi vi. Therefore, x bar is equal to summation xi vi divided by summation vi, which is equal to 11.5 millimeter. And you can do the same for the other two. It's okay. So for the other battles, yeah, you can find them on the book. It's okay.